Hi there. I need someone to let me know that they are actually watching these videos. Shoot me an email with the code word BELL and I'll send you a present. Okay, so we're looking at bell-shaped symmetrical distributions, and I have one drawn below, and I have it sectioned off for a reason. We'll talk about that in a second. So remember, with these videos, you get the most out of them if you've already gone through the material in the book first. I'm just trying to spearhead some of the trouble problems that students tend to have in their homework. So this particular video actually helps a little bit with section 2.4 and 2.5. So I'm just going to put that there as a reference. Okay, now, where am I? Okay, so our situation now is this, that we want to talk about what some of the characteristics are for this distribution. We're going to see it again in chapter 5, but we get introduced here, and it's introduced here because it has to do with standard deviations, and it has to do with a measure of position. Where are you in the rest of your distribution? So, looking at this data shape here, it says about 68% of the data lie within one standard deviation of the mean. So we know from reading our textbook that the mean falls here. You can call it x bar, you can call it mu, but either one, I'm going to just use mu for our mean. And then we're told that if we move one standard deviation away in either direction, that this would represent 68% of our population, or of our distribution. Now, how do you know that that's one standard deviation away? Well, you know because your book tells you. You like that answer? One, because mom says so. But this is one standard deviation this way, and then one standard deviation this way. So this would be plus, this would be minus. It's based on some calculus that we're not going to get into. Thank goodness is what most of us say. But we're going to buy that, okay? That plus or minus one standard deviation away. Now, if you go 2 standard deviations away, so 1, 2, and we go all the way to here, and we go back 1, 2, all the way to here, then we're told that from here all the way to here represents 95% of our population, or of our distribution. So 95% of the data would fall between those two values. And so now you've gone 2 standard deviations, so plus 2 and minus 2 to get to that spot. Now if you go all the way to here, now you've moved 3 standard deviations in either direction, and now we also are told that all the way from here to here is taking up 99.7% of the population. So that's like almost everybody, okay? All right. And so my general example for this is always IQ scores because the numbers are easy to play with. Typically, IQ scores are set up that they have this bell-shaped distribution with a mean of 100 and a standard deviation of 15. So a mean of 100, standard deviation of 15. And I'm saying you could draw this distribution. So 1, 2, 3 tick marks take us out to here. And 1, 2, 3 tick marks this way. And each tick mark is 15 points. So this guy would be 115, add 15 more, add 15 more. And the other direction you subtract. And ta-da, there you go. So for example, if I just wanted to look at from 85%, or excuse me, a score of 85 to a score of 115, then we know that 68% of all adults, so 68% of our population have an IQ score between an 85 and a 115. Well, where do you fall, right? And so that way we can compare you to the rest of your population. It's an easy one to talk about. All right, I'm going to live on the edge in a race because I have this magic pen that lets me do things like that. So if I want to talk about 95% of the population, 95% of the population have an IQ score between where and where? Well, according to our rule, 95% of the data lies between two standard deviations of the mean. And so I need to go 2 tick marks. 1, 2 this way, and 1, 2 this way. And we're talking about from here to here this time. So between a 70 and a 130. Now, just a little side note, Mensa is a genius group of snobs, let me just say right now, and they set their membership to be that you can't be a member if you don't have an IQ higher than 135. And then in our schools, for example, most of the special ed needs fall under 70. So you can see that 35 is probably unusual because it's falling above 2 standard deviations away, and under 70 would be unusual because it's less than 2 standard deviations away. So my question now would be, what percent of the population has an IQ that's less than 70? Well, you already know that 95% is from here to here, right? This is representing 95%. The total is 100%. So that leaves you, for this space and this space, that leaves a total of 5% for the rest of the population. Well, it's symmetrical. So half go here and half go here. So only 2.5% of the population has an IQ of less than 70. That's a very small percentage, and because of that, that's why we label them as special needs. It's not a usual thing. And on the flip side, this upper end, those are our gifted and talented kiddos. I also think they are special needs, just going to say that. Okay, now we can play with this all day long. We can say things like, well, because this is the bottom 2.5%, that a score of 70 is the 2.5 percentile. All right, something like that. So you've got lots of questions that are going to come up in your homework. I'm going to do one more example, and then please make sure you go back through your book and look at their examples. But our scenario this time, so I'm right here, is that I have a lifespan of a particular species of fruit flies that have a bell-shaped, nice typo, distribution. They have a mean of 33 days for their lives, and their standard deviation is only 4 days. So can you draw a distribution curve for this species? So we do our best to get this bell-shaped nonsense here, and you can see I draw super duper well. Part of that I'm going to blame on my computer. The mean is always in the middle for bell-shaped distributions. The mean, median, and mode are all the same value. So the middle is 33. Set yourself up with 3 tick marks that make it to the end of your curve, and 3 tick marks that make it to the other end of your curve. And then how do you get each tick mark? Well, you just keep adding 4. So 37, 41, 45, and subtract 4. 29, 25, and 21. So 99.7% of fruit flies have a lifespan between 21 and 45. 95% have a lifespan of 25 to 41. And 68% have a lifespan between 29 and 37. And it's a quick way to talk about your distribution without doing a whole bunch of math. So I've just put a few example questions on here of the type of things that might be asked in your homework in 2.4 and 2.5. So for number 2, what percentage of the flies would you expect to have a lifespan of more than 37 days? So go to your table and decide where that is. And more than is this way, right? But 37 is where on this information? Well, it's part of the 68%, right? So you know this. You know that between 29 and 37 is your 68. And you know that 100 minus 68 leaves you 32% for the rest of the population. And half of that's below and half of that's above. So then the answer to that question would be 16% would have a lifespan of more than 37 days. Okay? All right, so let's try that again. To try it again, I'm going to redraw it because I need something to squiggle on. So here's my picture with my fruit fly mean. And the third question says, what percent, that's what all these dots are, what percentage of flies would you expect to have a lifespan of less than 15 days? So clearly that's a typo because I didn't make it to 15. So let's change that and say that we want to look at less than 25 days. Sorry about that. So I go to my table. I don't have it redrawn, but I can. 25 is 2 standard deviations away. Did you notice that? All right, and I want less than 25. So I want here and under. Well, 25 was part of this interval. So 2 tick marks above put me at 41, and I know between here and here was 95. Well, 100 minus 95 leaves me 5%. But you got to cut that in half. So this number right here is 2.5%. And now we know how many fruit flies would have a lifespan less than 25 days. Okay, percentile and percentages are very similar, but you need to remember that a percentile means the percent below you. So when we talk about percentiles, we need to think of position. So what percentile does a fly with a span of 42 have? Man, I've got typos all over the place. I am so sorry, guys. I must have been half asleep when I was doing this. Let's not do, for number 4, let's change it to, my goodness gracious. We're going to change it to 41. So 41 days has what percentile? Sorry about that. Okay, so we go back to our list, and I still said 41. Okay, I meant to say 41, yay for me. So 41 again falls here. So we could use the same picture, all right? But percentile means what percentage is below you. So you have to add them up, big deal. 2.5% and 95%. So 41 days is in the 97.5 percentile. So a side note would be if I said my height is in the 78th percentile for women, then you would know I'm taller than 78% of the female population of my age group or something like that. Okay, well, I'm trying to keep these videos less than 10 minutes. That didn't happen this time. But to go back through this, the big picture again is using these rules here in order to draw your picture. So maybe that'll help you guys out with some of your homework from 2.4 and 2.5. Have a great weekend.